Okay, thank you. So can you see my screen?
Yes, yes, please do
Yes,
it on
sir.
the
Yes, sir.
slide,
Yes, sir.
Okay, fair enough. So as I already told you that I will be talking on the statistical data analysis. So, and I will be mostly covering the part of the parametric and non-parametric analysis. Okay. So basically you might be going for the field, or you might be having the setup in your lab, and you would be measuring something. Okay. You want to see some effect of any drug, or maybe effect of the your intervention, effect of the any policy in a survey or in a laboratory. So you might be getting the some kind of the data. So that data can be analyzed. Okay, so how you can analyze those data, that is the important aspect. How you can handle all those things. Okay, so basically how you can do this data analysis, that's depend on the what kind of the objective is with you. Okay, so what kind of the objective is with you, and then after that you certainly find that this is the objective, and the for the that objective I can ask the that much of the questions in the survey, or I can do that much of the activity to bring out the information from the patient, from the experiment. So basically you would be following the some kind of the research activity. So I'm just starting from the very beginning, that what is the research. So how you can understand the research. So research is nothing but it is a process wherein you can do some kind of the activities to look about the some problems. Okay, and that can be done systematically. That is we can understand that it is the research what you are doing in maybe in your PhD work, or you are supervising your student, and like that. Okay, so it is a process wherein activities are carried out systematically to find the solution of a problem. So let's say I would like to work on the effectiveness of the vaccines for the COVID-19. I would like to see that what are the what are the challenges you will face to give the new policy for the society. And then these are the there is some activities. Okay, so to look up the any research problems, so there is some activity that you need to do. So what is the identification of the problem, and then after that you trying to formulate your hypothesis, and then you will go for the data collections, and finally you will come up with your data, and that data can be data can be deal with the data analysis. Okay, so how you can do the data analysis, that is the important part here I would be discussing. But before of that, what is your identification of the problem? So what are the problem, and what is your objectives is you are looking in your research. That is we are trying to help you to bring out the analysis part. Okay, so identification and the formulation of the research problem is basically the selection of the research area where you would like to work. You would like to work on the patient care, and you would like to see the impact of the Ayushman Bharat on on a particular village. Okay, and you would like to work in the patient hospitals, or maybe you would like to see of the management of the any policy. So this is the basically the selection of the research area. Then you are reviewing the literatures and the theories. So these are the two parts where you will be seeing that what are the literature and theories available. Focusing the research topic. Okay, so then evaluating the research problems, formulating the final statement and the research problems. Then this is the key point for any research. Why I'm discussing, although I would be discussing on the part of the analysis. But this is also the important part, how you are looking up the identification of the problem. And if your problem and the objective is very clear, so that you can apply the statistical test appropriately. Okay, so that is the important part. So there is a linkage between the problem which you are formulating, that is linking with your types of the data, what question you will ask from the survey or from the experiment, and then after that it is also linking with your analysis part. Okay, so how you will be doing those all. So this is the basically the part of the analysis. Okay, so we will talk about the what is the research process. So research process, we already discussed that the primary part, we will start with the my research process with
So
the
your slides are not moving. So can you do it in the slide mode?
okay, so it is on slide mode, but
okay, maybe it is not visible here.
Okay, so now it is visible.
Just a minute. You can share it again. Actually, I think it's not in the slide. So.
Okay. Now you can see.
Yes, fine.
And you can see my next slide as well.
No, this is the research process only. Yes,
Next.
Now it's changing.
Okay, fine, fair enough. So we was talking about the research process. So we initiated with the what kind of the problem you are looking up in your research or in your PhD work, whatever you are doing the project. And then after that, you will go for the review of the literatures and the based on the theory and the whatever the past work is available with you. And then after that, you will be going for the formulation of the hypothesis. As you are linking with the statistical test or statistical analysis, that means you must have the some hypothesis. Okay, so hypothesis in respective of the statistics that you might be having, so that you need to formulate your hypothesis. And then after that, you will talk about the design research. Okay, so you need to design how you will be collecting your data, and then how you will be bringing out that information from the field or from the experiment. So this is the basically you need to so you will be going for the analysis. Then after that, you bringing the data from the field, and then after that, you will talk about the analysis of the data. And this analysis of the data is basically nothing but whatever the hypothesis you formulated, that needs to be tested. Okay, that needs to test it with the help of the statistical analysis. Then after that, we will talk about the interpretations, and then after that, you will be submitting your reports and then other activity. So after this, you can see that there are the lot of these packages available for the statistical analysis. So you can see, you might be familiar with a lot of the open source software is available, and then the paid version is also available. So we will talk about the SPSS statistical package for the social sciences, Stata, R, Minitab, AppInfo, SAS, and many others. There are the available. Okay, so even though you will see that a lot of the qualitative software is also available, for example the NVO, Atlas TI, and these are the software is available for you. And even the qualitative data analysis can be performed with the help of the open source software, which is nothing but it's R software. Okay, so before I will go ahead, then I need to discuss about the scale of measurement. So how you will be measuring the question which you will ask the field, or in the case report form which you will be deploying in case of the patient's informations, or maybe in your experiments. So we will talk about the scale of measurement. So this is the scale of measurement which we will talking here. That's basically the types of the data which you will deals in the part of the analysis. Okay, so here the nominal, what is the nominal? So nominals we can define it is a classification, no order, distance, and origin. So basically what is the nominal? Nominal is nothing but the question which you will ask like that, what is the gender of the patient? Okay, so is that male, female, and transgender? That's you are asking. Okay, so this it's classifying, this is the male, female, and the transgender. So this is the nominal. As we will see that what kind of the patients is coming from the rural or urban populations. Okay, so you just asking the is this rural urban? Okay, so this is nothing but it is just classifying these are the rural patients and these are the urban patients. Okay, so this is the nominal. Okay, so this is the nominal types of the data. Then we will go ahead, that is the ordinal. Ordinal is nothing but it is the classification, order, and no, distance, and origin. So classifications and the order. Okay, so for example there is a classifications means you will be saying that some classification is there, but there is a order is also there. So basically what is the meaning of this order? There is some hierarchy is there. Okay, some hierarchy is there, some order is there. For example, in if you will be assessing the patient's pain, then you will be saying that it is the pain is mild, moderate, and severe. So this is the one of the hierarchy. There is order is access. You will say that your students, you are first division, second division, third division, fourth division. So this is also a part of the ordinal data. Okay, so as you will give the feedbacks to the my presentation as well after this presentations. Then you will say that I am fully satisfied, not satisfied, not fully satisfied. So this is the basically once you will be giving the feedback. Okay, so customer satisfaction or perceptions. So these are the truthness. These are the can be assessed with the ordinal kind of the data. So there is some hierarchies there. So that is ordinal. Now after that you will talk about the interval. So interval is classifications, order, distance, but no origin. Okay, so here you will be having the some distance. Okay, so here for example if we will talk about the sorry, so we will talk about the classification order and distance. So here you will be having the how many the patients who are appearing for the follow. Okay, so and how many patients are having the cancer disease. So for example these are the things. And in the ratio, the classification, order, and distance, natural origin is there. So this is the basically if I will be talking about the what is the blood pressure of the patients. Okay, what is the age of the mice respondent. Okay, and these are the an example of the interval and ratio. Most of the time in SPSS on other way it can be considered as the one kind of the data, interval and ratio. Okay, only the differences is that natural origin, as you know that we are measuring the temperatures, zero temperature has the some meaning. So that's considered as the natural origin. Otherwise, we will talk about the if we will talk about the how many the classes you attended from this one, how much money you spend for the every day. So these are an example of the interval and ratio. So this is the basically the types of data. Why we are discussing this one? This is the very important important part, that scale of measurement. So why it is important? Because you need to understand that whatever the question you will ask, that's have some types of the data, and then we can link that what kind of the sort of analysis you can plan. Okay, you can predict that you will be applying this kind of the analysis. Okay, so basically after that, once you will have the data, means you gone for your data collections, and then you come up with some data, and then after that your next step is that analysis strategy. Okay, so what kind of the strategy you will opt or maybe what you will plan. Okay, so that is the next question for you. So how you will deal with this thing. Okay, so basically analysis strategy means that how you can handle your data, what you will look first, what is your plan. Okay, so what is the commonly things can be done in the analysis strategy. So first you need to understand your data. So how your data is look like. Okay, so is that really the free from the errors. So we will do some quality checks of my data, and then after that I will plan for the another part of the data for the analysis strategy, or basically I will think of the what kind of the analysis I can do. So this is the what do I plan to do with the data is the first I need to understand how my data is look like. So basically I need to describe. Okay, so I need to do the descriptive statistics of my data. So descriptive statistics is basically I need to see that how the patient's blood pressure is lying in my data. Okay, so that's I need to look up with the mean, median, and standard deviations and minimum maximum values. So this is the I need to understand that how the genders is looking up here in my data. So how many numbers and the percentage for the male, how many number and percentage for the female, how many number percentage for the for the transgender. So this basically I need to see that what is the descriptive statistics of data. So it will help you to see see the structure of your data is really is distributed well, and whatever you thought of that is covering or not. That means other ways that you can say that are you doing the enough quality checks of your data. So this will help, can be done with the help of the descriptive statistics. That is nothing but for the interval and ratio data, you will be going for the mean, median, and standard deviations. For the categorical data or for the qualitative data, you will be going for the number and percentage, or maybe you can explore the some of the graphs. Then after that, explorations. So really, how many subjects are allocated to the my gender, which is the female, because that is the my important part of my analysis. So I can go for the explorations, that is called the cross tabulation of the variable. So I can see that how many the genders who are in the rural, or how many in the urban. Okay, so is there what is the distribution. So I can do the two categorical cross tabulations. Okay, so I can bring the two categorical data, either nominal ordinal or maybe ordinal. So I can do the cross tabulations. Then after that I will move for the discovering the differences. So basically the hypothesis testing of your data. So this is now coming on the inferential part of the analysis. Okay, so here I can do the testing of the hypothesis. So whatever the hypothesis previously we discussed, or we framed for according to my objectives, that needs to be tested here. That is called the discovering the differences or hypothesis testing. And maybe you can also go for the finding the relationship. So relationship means you would like to see that impact of the one variable on the others, or really they are related or not. So you looking up the relations, then you will be saying that it is a measure of associations. And we can also go for the regression analysis. Okay, so this is the basically the strategy you have broadly in your mind. Then after that, specifically according to your objective, you can plan for the other part of the analysis. Okay, so this is the structures which is in my mind, and then after that I can plan for the next part. So here I can also just telling you about the what is the quantitative and qualitative. So the main emphasis on the qualitative and quantitative is the word theory and building the inductive structures conceptual. So basically once we will talk about the qualitative, so how I'm looking by my face is really this speaker is energetic or not. Okay, so you are just seeing the pictures, and then based on the pictures you can analyzing. So this is nothing but it is a qualitative analysis. Okay, just seeing that what kind of the outcome you will see from the picture of my office. Okay, so this is the basically I can analyze the word, pictures, and the text and the data. Okay, so this is the nothing but it is a qualitative. Once we will talk about the numbers. So how many lectures you listen before of this? Okay, and how many lectures you listen from this training program. So this is the basically once we will talk about the numbers and the theory. So this is the basically a quantitative. So in the quantitatives you can do a lot of the analysis. Okay, as you can perform the inferential statistics, or in case of the qualitative analysis, you can go for the text and image analysis, thematic, and the content analysis. So this is the basically the structures which you can understand, that the categorical data analysis and the quantitative data analysis. We will come up on the main task which we have to do in these presentations. That is the parametric method. So here we will talk about we will discuss on the parametric part is the what is the one sample t-test and what is the t-test, independent t-test, or maybe we will talk about this is nothing but also called as the two sample t-test. Okay, and then after that we will talk about the paired t-test. Okay, paired means once you will have the paired samples, and then after that we will talk about the one-way analysis of variance. So these all will are part of the parametric methods. So parametric method is nothing but while you doing the hypothesis testing, so there might be some assumptions. So those assumption is fulfilled and the assumption met by your data, then you will go for the parametric analysis or parametric test. If these assumptions are not met, or these are assumptions are not fulfilled with your data, then you will go for the non-parametric method. So basically this is the differences which you will see in the parametric and non-parametric. Means your data is normally distributed, then you will say that it is the parametric methods. You can opt parametric methods. If it is your data is not normally distributed, then you can go for the non-parametric methods. Okay, so let's see the statistical methods, what you will opt for the discrete outcome variables and continuous outcome variables. So let me go back to continuous outcome variables. So continuous outcome variable is nothing but it is the interval and ratio. Okay, so as we discuss about the blood pressures, hemoglobin, and how many times you will how much money you spend in a day. So these are the nothing but these are the example of the continuous outcome variable. Discrete outcome variables means you will talk about the categorical data, and sometimes we also talk about the how many patients are there who have follow visit. Okay, so this is the basically here you will go for the chi-square test, which are Fisher existed, logistic regression, survival analysis. So this chi-square test, it is a non-parametric methods where we will see that the independence of the test. Okay, so or you can say that it can be the chi-square test used to see the goodness of the fit, or it can be used for the independence of the your categories. Okay, so this chi-square test is used, then you can go for the Fisher exact set. If some assumption is not met in chi-square, then you can plan for the Fisher exact test. Logistic regression is nothing but once you will have the dependent variable of yes and no, or who will win in the elections, that means yes, no, survive or die. In that cases, you will might go for the logistic regression. Survival analysis. So in survival analysis, if patient is died or patient is survived, in that case, we will go for the survival analysis. And this is the part of the discrete outcome variables. Now we will come up on the continuous outcome variable. So continuous outcome variable will start from the t-test. What is the t-test? Then pair t-test. So t-test is independent t-test or two sample t-test. We will say that because we will be having two samples from the populations. So this is the t-test. Pair t-test means same patients are there, but we will be assessing at two different time intervals. So for example, we will talk about the pair t-test is you giving you just looking the what is the temperature of the patients, and then after that you giving the medications, and again you will be assessing the same patients. Okay, so this is the pair t-test. Then we will talk about the analysis of variance. So analysis of variance is nothing but it is the once you will have more than two samples, then you can go for the analysis of variance, analysis of covariance, and the linear regressions, where you will talk about the simple multiple Wilcoxon rank sum test, Wilcoxon sign rank, and correlation. Lot many things are there here in continuous outcome variable. So basically in the continuous outcome variable you can do many you can do analysis with many variables. Okay, so it's up to you means what kind of the analysis you can perform with the continuous data. So you can do a lot of the analysis. So here that is the privilege is with you, means you can apply as much of as analysis you can do with the continuous data. So this talk to us that whenever we framing the questionnaire, that's we need to keep in mind that again we need to do out of the top, or maybe out of the and we will be doing the basically analysis. So that's we need to keep it. Let's another structures here. I will talk about the parametric and non-parametric. So the first step here, this is the parametric, and we I wrote in this is x is equals to 2 and y is a normal. So if it is there are the two sample and y is a normal, means your data is normally distributed. That means you can go for the student t-test if it is unrelated samples are there. If they are related samples, then you can go for the pair t-test. Okay, same patients at the assessment is at two different time interval. For example, your assessment was done in the from very first day of your workshop, and then after the end of the workshop, because you gone through this much of the lectures, and then after that we are assessing from all of you. That is called the pair t-test. Okay, then x greater than 2 and x greater than 2 and y is normal. So if your sample is more than 2, and you will be having the normal. Okay, so x greater than 2 means you will have more than two samples. Okay, and it is the assumption is met, means normally distributed data. Then in unrelated you can go for one way ANOVA, and repeated you can go repeated measure of analysis of variance. Okay, so repeated measure of ANOVA. If you will go on the other side, that is the non-parametric. So non-parametric means again you will take corresponding to the the t-test or pair t-test. So this is the basically x is 2, means you will have two samples, but the normal, not normal. So here these are unrelated and related. So this is here you will going to use Wilcoxon's rank sum test, Wilcoxon sign rank test in case of the pair t-test. Okay, so this is the analogous to the pair t-test. Similarly, if we will talk about the more than two samples, means x greater than 2, means there are the more than two samples, not normal. Not normal means they are unrelated, then you will talk about the Kruskal Wali, and if they are related, then you will talk about the Friedman test. Okay, so these are the bifurcations you can see here. Then you can understand that how you can do the analysis of these all. Okay, so this is the structure which we are going to discuss one by one, and how you can apply these kind of the analysis. So let's we will start with the one of the most commonly non-parametric method is used is the chi-square test. Okay, so what do you understand by the cross tabulations? Okay, so cross tabulation, as we already discussed that the cross tabulation is nothing but you will have the two categorical variable, you will have the two nominal data variables. So you want to see the cross tabulation between 1 and 2, the options of the 1 and 2. So is your respondent are in the rural, urban, or what is the gender of this one? Okay, so how many are the females who are staying in rural, how many are male who are staying in rural, and how many are transgender who are staying in the rural area. So this kind of the cross tabulation you can see with the help of the cross tabulations. Basically, you can create the cross tables between the two categories, okay, two categorical variables. But this will give you the idea. So is this will not show you the is really this is the a good association between these two category or not. That can be tested with the help of the chi-square test. Okay, so chi-square test is the non-parametric method which is very commonly used for the categorical data or nominal data. Okay, so here we will see that what is the chi-square test. So it is the useful test for involving the nominal data, but can be used for the higher scales, as you can also use the other scales, mean other types of the data you can use. Typical cases where the person, event, or object are grouped in two or more nominal categories or the classes. Okay, so for example, the flavor A, B, C, D, favor, undecided, against, yes, no, rural, urban, male, female, transgender. So if such kind of the variable is with you, okay, then you can go for the chi-square test. Then a chi-square test is just telling the what is the association between the two categories. Okay, so that can be done with the help of the chi-square test. Now we will come up on the one sample t-test. So basically we will have the one sample, okay, and then we want to see that. So a parametric method is mostly used to see the differences of the mean value. Okay, so how the differences of the one sample mean value with the some hypothetical value, or differences of the mean value of one sample with the some predetermined value. Okay, so that we want to do with the help of the one sample t-test. So one sample t-test is used for basically one samples. So one independent samples, so comparison between the one group of the subject. So you will have, let's say, patients, or maybe subject, or maybe participants, respondent, and you want to compare the mean response from one treatment group to the some existing value or hypothetical value. So that you want to see. So for example, H naught is nothing but mu is the your sample value, and the some hypothetical value is 105. Then alternative hypothesis is that mu is not equals to 105. Then in that case you can use the t-test. Okay, so this is the t-test formula, and it is for the one sample t-test. So basically here you need to do x bar minus of mu. Okay, so mu naught or s by root n. Okay, so this is the basically it will give you the t calculated value, and then you can compare with the tabulated value. Otherwise you can go for the with the p value, and then based on the p value you can make the decisions. Okay, so this is, so far we talk about the one sample t-test. Okay, now after that we will see that how you can do with the two sample t-test. Okay, so what do you understand by the two samples? So basically two samples means let's say if it is I'm just comparing some IQ level of the JNU student and the DU student. Okay, let's say I bring out the 100 student of JNU, 100 student of the DU. Okay, so I want to do the is that IQ level of JNU student is same with the IQ level of the DU. Is really that's true, or is my assumptions? So in that cases, so samples are the from the two different populations. So that is the population here. In my case is the JNU and DU. So here we can compare the mean value of this IQ level. Okay. So that in that case, we can go for the two sample t-test. Okay. So basically you need to understand this. You must have the two sample and these should be independent samples. Let's we talk about the more on this. So t-test two independent samples, the comparison between the differences group of the subjects. Okay. So these are the differences of the subjects and compare the mean responses from the two treatment groups. So let's say another example, if we are giving the two treatments, one is the treatment in paracetamol and another treatment set of people getting the placebo. So we are comparing the mean value of these two samples. So that is sort of the analysis we are doing here in case of the t-test. Now we will talk about the pair t-test. So pair t-test is something where we will have one sample with related value. Okay. So the patient is the one. So we will be having the Genie student, but before of the admission time, or maybe let's say we will say that during the admission time, we will assessing their IQ level, and once they are leaving from the JNU, then we are assessing the IQ level of the same students. That means we will be saying that what is the change from the from IQ level of pre-student and the post or maybe pass out student of the JNU. So that I want to see with the help of the peer t-test. Okay. So here some example are blood pressures change from the baseline within the group and mark obtained before and after class taken by the ICT tool. So this is the basically the peer t-test. So basically it can be used pre and post. So pre assessment is there and some intervention is given, then post assessment is there. Similarly, before and after. So these are the commonly examples where you can understand the analysis of the peer t-test. Okay. Now we will talk about the let's broadly we discuss the two sample t-test. So basically the concept is there is clear. We are comparing the mean value of the two samples. So this is the mean value of NU students IQ level, and this is the DO student. Okay, we are comparing the mean value of IQ. So that's we are looking up, and this is the basically t-test is comparing the mean of two different groups of the subject is compared as. So two different groups is basically one group is your JNU, another group is the DU. So these are the this is nothing but it is the student t-test. So basically here this is the formula. So I wrote in the different ways. So this is the T is equals to mean 1 minus of mean 2. So this is nothing but differences in mean and the variable T, the S square by N1 and S square by N2. So there are the two samples and N1, N2 is there, S square S is the variability. So this is the differences of the mean divided by the variability. So it will give you the T is a statistics. Okay. So is the differences significantly different from the zero when we compare with the variability? So that's we want to do in the two sample t-test or student t-test. So these are the some assumption for the student t-test. So the samples are independent and bell-shaped distributions like a normal distributions. Bell-shaped curve is center around 0 and the tails are slightly thicker than the standard normal bell curve. Okay. And when the sample size exceeds the 30, then t distribution will be the same as the standard normal distributions. Okay. So this is the assumptions for doing the two sample t-test analysis. Okay. So let me explain one by one what is the samples are independent. So samples are independent. If it is, we talk about the IQ level of JNU students. So JNU student are independent and DU student are the independent. So in that sense, these are the independent. So first assumption is fulfilled that these samples are independent. Bell-shaped distribution like a normal distribution. So once we will draw the distributions of the data, whichever we collected from these two places, that should be a normal. Okay, so this is the bell-shaped like a distribution. Mean, median, mode are quite similar or maybe close to the similar in the normal distributions. Okay, so this is the assumption which you need to look up. So whenever you're going to apply the t-test, then you need to check these assumptions. If these assumptions are fulfilled, then you can go for the another sort of analysis. Okay, now we will talk about the student t-test. So is the differences larger than the expected by chance? So here you can see that this is the observed t statistics, and here do not reject h naught. So if it is the value is coming up here, then you will see that do not reject the h naught. So if it is this value is going from the beyond of the critical region, then you will make the decisions and p value will be rejected h naught if the value is lying beyond the not not rejection regions. Okay, so here the based on the p value you can make the decisions, is that your null hypothesis is rejected or it is not rejected. So this you need to do with the help of this diagram. You can easily understand that how this p value is rejected. So basically my purpose is that my hypothesis is that the mean IQ value of the JNU student is the same as the mean IQ student of the DU student, or they are not same. So that's you want to look up. So this can be done with the help of the student t-test, and this you can see, and you can, if it is, you can reject if this value will go beyond of this one. So here if it is this coming up, then you will be saying that you are not rejecting h naught. So is the differences larger than expected by chance, or maybe it's due to the based on the data? So when we observe the t statistic is so large, if it is t value is so large in the magnitude that that it falls outside the region marked by the two critical points, and we conclude that the observed difference is larger than the expected by chance. So if it is the t value is very high, so large, means that it will go from beyond of the critical region. Okay, so in that cases you can reject the null hypothesis, and you can conclude that the observed differences is larger than by the expected by chance. Okay, so there is a alpha is 5% chance that we made a wrong decision. So while we are testing the hypothesis, we will talk about the level of 5% level of significance, or maybe a 1% level of significance. That's we can make wrong decisions 5%. That's we will be including in my analysis part. So let's say this is the example of the t-test, that's students marks 1 and student marks 2. So here these are there are the 10 observations, and this is the mean value and this is the standard value, and here you can find out the calculations. Okay, so you can just find out the mean, variance, and the t value. So here you can see that the t value is 2.176768. Okay, so this is the t value, and here you can also find out the p value. So p value can be seen that 0.0215. Okay, so this is the p value. So based on this p value you can make the decisions. So are you going to reject the null hypothesis, or you can fail to reject the null hypothesis? So this you can do with the with this output. Okay, so you can just play and then you can make the decisions. Okay, so there are the two ways, um, as already we discussed. So I think my screen is the full screen. So as I talk about that, either you can make the decisions with this the observed difference is so large. If p value is so large, that means it will go beyond of the critical region, and otherwise you can go for the p value. So this is the p value. So this is the p value. From this p value you can make the decision, are you going to reject the null hypothesis or fail to reject the null hypothesis. Okay, so let's see how you can perform the this t-test in the SPSS as well. So I'm just demonstrating through this slide only, and then later on you can also do with the SPSS. So you can go for the compare mean using the SPSS. So you can go for the analyze, then compare mean, and then here one pop-up will come up on the independent sample t-test, and here you will say that it is a dichotomous group is there. So it's, let's say, JNU group is there, DU group is there. So you can give the some numbering, and then after that you can talk about the what is the IQ value. And this, after that you will talk about, you from here only you can also do the pair t-test, and here this one, and from here as well you can do the one-way analysis of variance. So here you can put the factors, so what are the factors are there, and then after that you can bring out the value of this one. So this is the basically the structures of the parametric methods. Okay, so you can perform the parametric analysis from the based on this one, and you can use this for the further analysis. Okay, so this is the giving you clear idea, means how you can make the decision. So there are the two ways. You can go with the p value, or just you can look up the t value, and then after that you can make the decision. So I think this is the clear for all of you. Now I can go ahead with the next part, that is the analysis of variance. Okay, so analysis of variance is the next part of the t-test. So here, once we will have the more than two samples. So far what we are doing, we are having the one samples, that is the JNU, DU. Now we will have the more than two samples. For example, if we want to see that the IQ level of JNU student, IQ level of DU student, IQ level of Jamia Millia student, Jamia Millia Islamia, then how you can do? So for this case, you can see the mean IQ value of these three institutions is same or they are differ. So that can be done with the help of the analysis of variance. So we talk about the analysis of variance. So when we want to make the statistical inference about the set of mean from more than two treatments group. Okay, so here we talk about the more than two treatments group, means the treatment group is, for example, JNU, DU, and the Jamia Millia Islamia. Okay, so although this more than two treatments means are compared. So here again we need to see the means of 1, 2, 3 are compared, and this procedure is called as the analysis of variance and the total variability. Okay, so here we will also look up the variability within the data amongst the group. So is the data is partitioned to test the differences among the means. One way analysis of variance is nothing but we will have the here the F test, which we are going to use to test the more than two samples. And so far in the t test, we are using the t distributions. And what is the basically the definition? The compare the sample variability between the group within the variability with the sample variability within the group. Okay, so this is the formula of the test statistics, that the differences in the mean value and the variability of the differences. Okay, so far you can recall the x mean of one sample minus mean of other samples divided by the variability. Okay, this was we did in the t-test. Now same things we also doing in case of the more than two samples, differences of the mean value that we are doing here, the variability of the differences, and then this is nothing but it is the f test. Okay, so this is we are going to do in analysis of variance. Now you can see this is the mean where if you can see that this pictures, and here this picture shows that 0 mg dose, 10 mg dose, and 30 mg dose is there, and these doses are now you can see that how this mean response value are is closely associated or far away from the this one, so that you can check with the help of this mean response value. Okay, so basically the mean response is, suppose any mean response is value is coming up, so other value, each value is far away from this mean response value or they are closely associated. So that is the my concern. So if it is much far away, so that is the I need to reduce that variable, see, variability. So basically this is the my purpose, so I can reduce these variability among the from the mean response value to the each respondent value. Okay, so this is the basically I'm trying to do here in case of the analysis of variance. Okay, so this is the picture, it will itself telling you you want to minimize these kind of the errors. Okay, now in the next part, analysis of variance is it is creating the model that is the yij is equals to mu I plus some errors. Okay, that is the um, so yij is nothing but the response of the jth subject from the jth ith treatment group, and mu I is nothing but mean of 1 2 3 samples. Okay, and last one is the nothing but it is the random error associated with the with these mean values. Okay, so this is we are trying to understand in case of the analysis of variance. So again, now we will go back for the assumptions while we are doing the any testing, then you have to look up the assumptions. So these assumptions are the epsilon ij are independent, the errant terms are independent, and these errant terms are normally distributed with mean 0 and equal variance of the sigma square for each group. So that's we are going to be understand from the analysis of variance. Overall test of the equality of the treatment means we are just saying the treatment means of the one sample, two sample, and three sample are the same, as we are doing the mean IQ of JNU, DU, and the Jamia Millia Islamia are the same or not. So this is basically the null hypothesis, all mu i's are equal. So the mean IQ of JNU, DU, and JMI are the same, and that is the in general we will write all mu i's are equal. Alternative, at least one mu i's differ from the others. That's we are looking up here. So here for that we will be using the F distributions, F statistic, and we can obtain the p-value, the probability of the observing the test statistics as extremes observed value by the chance alone. Okay, so this is the decisions. How you can make the decision? P-value is less than 0.05, that means rejecting H naught. If p-value is greater than 0.05, that is fail to reject H naught. Okay, so this is the decision rule made by while we are doing the analysis of variance. Okay, so this can be done for the one sample t-test, two sample pair. That means you will be make the decision as by this way. So p-value is less than, then you can reject H naught. If p-value is greater than 0.05, then you can say that fail to reject H naught. When we will talk about the when overall F test is significant. Okay, Significance, we are interested to know that which treatments means are different. Okay, significant means then p value is less than 0.05, that means for f test is significant. Okay, and significance, then you want to know that which uh, group is differ from the others. So JMI mean value is differ with the Jamia, or JMI JNU mean value is differ from the Jamia, or JNU mean value differ with the DU. So which one is differ? Okay, that's you are interested in case of once you will be getting the significant p value. Okay, after that, multiple comparison procedures are used to answer the such questions, and pre-planned comparisons are to be made. Then you can use the contrast and the estimate statements for to compare the mean values. So this is the example of one-way ANOVA, and here you can see that ICT class are there. So this is the one flavor of the ICT and the marks of the student in flavor 2, in marks of the student in flavor 3, and here you are going to apply the one-way analysis of variance. So F is the 3.35, and this is the p value. So p value is 0.09, and you can easily understand that is the less than 0.05 or it is greater than 0.05. Accordingly, you will say that it is significant or it is non-significant p value. Okay, so this is the analysis table. So it will give you the sums of a square, degree of freedom, means of a square. So you do not go for the calculations, but you can understand that the p value and the f overall. Okay, so based on the p value, you can make the decisions. That value can be reported in your journal wherever you are going to be submit your papers. So this is the things. Now we will come up on the assumption part. So as you can see, the figure 1 is normally distributed. It is clearly seen that it is not normally distributed, but figure 2 is normally distributed. So figure 2 is normally distributed, but with mean value mu1 and mu2. But if you will see the variances, okay, so what is the variability between these two distributions? Okay, so there is a variability is this axis, and now we cannot use the um, we cannot use the analysis of variance if these are violated. Okay, so in the first figure it is not normal distributions, then in the second figure it is normally distributed but unequal variances are there. It means that there is a variability in the data. In figure 3, the equality of the variance so is the most important assumption of in analysis of variance, and if the variance are not equal, then the statistics is not valid. Okay, so this must be have the equal variability. Okay, so if you will see that this picture and this pictures, then you can easily understand that equality of variance or close to equal, then you can going to apply the analysis of variance. Okay, so this is the normal distributions with equal variances. Now we will come up on the other sides. So far we will talk about the model assumptions are there. Okay, t-test assumption is there. If they are violated, then what we need to do? Okay, so what are the option is available? So you need to obtain the standardized residuals. Recall that the standardized residual follow a standard normal distributions. So check the 68% of the standardized residuals are between the -1 and 1, and 95% in -2 to 2, and rest in the -3 and 3. So this is can be seen the assumption about the your error terms. Okay, so if the plots of the residual shows some concern, then use the transformation. So there are the two ways. If it is you are not following the assumptions, then what you need to do, you need to transform your data. Okay, so you can use the log transformation, you can use divide by the sum value, and you can reduce their magnitude. So this kind of the transformation can use, and then again you can check the assumptions. Okay, so if it is they are fulfilled, then you can go for uh, the parametric methods, or you can go for the analysis of variance. If the transformation does not make, if you can apply the log, and even then your data is not normally distributed. Okay, your data is not normally distributed, then you can go for the non-parametric methods. Okay, so you can go for the one-way analysis of variance, that is the Kruskal-Wallis test can be used in place of the one-way analysis of variance. Okay, so this kind of the option is available if you can go for the transformations, and then if it is your data is not coming in the normal distributions, then you can go for the non-parametric methods. So now we will talk about the what is the non-parametric methods. Okay, so the complexity and the wealth of the data demands the non-parametric techniques. Okay, so as you will see that you will get the complex data, it's not normally distributed, the variance are not equals of these two samples. That is the can one test the phenomena or hypothesis using the least or minimum amount of the assumption in analysis. Okay, so here we don't bother about the assumptions, so that's why we will going to use the non-parametric methods. So we talk about the what is the non-parametric methods. Okay, so this parametric, non-parametric versus, so we already discussed about that. Parametric means you need to follow the assumptions. If these assumptions are not followed, then you can go for the non-parametric. So if one or more both of the parametric assumptions, normality and the equal variance is violated, okay, then the non-parametric test for the equality of the treatment means is more appropriate. Okay, so in that case you can go for the non-parametric test. The simulation test suggests that parametric ANOVA is fairly robust against the departure of the normality, but not the unequal variance. So sometimes you can use, if your data is not normally distributed, then you can go for the ANOVA. But if it is the variance is unequal, then you cannot use the parametric method. So in general, the parametric ANOVA is preferred test in the most cases that the data for the continuous and the small sample size. Rank based, and that is the non-parametric. Now we are coming on the non-parametric method. So what you will do in non-parametric, earlier in the parametric methods, what you are comparing, you are comparing the mean values. Okay, so there you are just measuring the mean value, but here in this case you will be using some ranks of the data. Okay, so you giving the ranks to your data, and then after that you can assess. Okay, or here sometimes you can use the median value, and then you can estimate your mean differences value. So this is the differences in the techniques of the parametric and non-parametric methods. So applicable when the data is not normally distributed, or when the group variance are unequal, then you can go for the non-parametric test. Instead of the mean, in the non-parametric test, compare the distributions. Okay, so basically we are comparing the distributions. Intuitively, non-parametric methods compare the centers, medians of the two samples. Sometimes we will compare the median value. For example, null hypothesis, the median value is same as the other treatments, and they are not same. So replace the data with their ranks. Okay, so we will replacing the data with the ranks. So that is the strategy which we will be opting in non-parametric methods. Okay, so this is the non-parametric methods. Next, we will talk about the Kruskal-Wallis non-parametric overall test. Okay, so it is the analogous to one way of analysis of variance. Okay, so in one way analysis of variance, rank all the data. So rank one is the smallest value, and without regard to which treatment group they are in. Okay, so we are ranking to the all this value, and then calculate the sum of the ranks. For example, rank R1, R2, Rk from the each K group, and then compare the each treatment rank with the overall value. So basically, this is just I'm trying to explain you how it is calculated. Okay, but you will have the various options. Means you can go for the statistical software and then you can do. But what basically what strategy we are changing here in non-parametric, that's I'm trying to explain you. Okay, so this is the Kruskal-Wallis, means more than 2 samples are there, then you can use this formula and then calculate the test statistics, compare the results with the value of the chi-square distributions. Large chi-square means the data do not support for the null hypothesis. Okay, so that's you can make the decision. If it is you will get the higher chi-square value, then you can say that it is going beyond the critical value, and then you can go for this one. Okay, so test statistic is based on the appropriate chi-square. Here we are going to use the chi-square test and does not use any assumption about the distributions, more robust to the outliers if it is your data is having the outliers value, and in that case it is the more robust cases, does not use all the informations in the data, so it is the less powerful than the parametric ANOVA. So this is the not much that effective, but this is the only alternative if you will have the very different data. If or in that case you are not following the assumption, then you can go for the non-parametric methods, and like this Kruskal-Wallis you can use it. Does not use all the information in the data, so it is the less powerful because you are using the ranks, or you are using the median value, or you are just using the distribution. So this makes that we are not using the all the values, so that's why it is the less powerful. Moderate sample size is usually needed for the more powerful test. So this is the Kruskal-Wallis non-parametric methods. Now we will see that the others one, that is the parametric versus non-parametric. So if it is t-test is there, then you can go for the Wilcoxon rank sum test. If pair t-test is there, then you can go for Wilcoxon sign rank test. Pearson correlation, then you can go for Spearman rank correlation. And one way ANOVA, that's we already discussed the Kruskal-Wallis test. If you are having the repeated samples, means the same subject patients can be assessed at different time interval. So first time interval, second, third. So in that cases, you can go for the Friedman test. Okay. So this is so far we discuss about the parametric and non-parametric. You can see there is a alternative method is available for parametric to non-parametric. Okay. So what strategy you are using in the non-parametric means you don't bother about the data assumptions, and then you can go for the non-parametric methods. Okay. Now we will see that some other classes. So we talk about the chi-square test. We talk about the parametric method. We talk about the non-parametric methods. And now we will talk about the family of regression analysis. So family of regressions. So it's depend on the what is your dependent variable. Okay. So if your dependent variable is nominal, then you can sort of certain regression analysis. If it is the continuous, then you will have a certain test is there, certain regression test is there. So you can use the according to the dependent variable. So dependent variable, for example, the production of any crop is depend on the rain, as well as from the what kind of the fertilizer you are using. Okay, so my production is kind of a continuous variable, then I can go for the regression analysis. Means if it is yes and no kind of the data, then you can go for the logistic regression. So if it is your nominal dependent variable is the two labels, means yes, no, fail, pass, then you can go for the logistic regression. If you will have the more than three labels, then you can go for the multinomial logistic regressions. If it is the ordinal dependent variable, then you can go for the ordinal logistic regressions. Okay, so if it is your dependent variable is interval, then again you will see the lot many assumptions, and if those assumptions are fulfilled, then you can go for the linear regression. In case of the one independent variable, if more than two independent variable, then it is called multiple linear regressions. And similarly, there are the lot many types are available about the regression analysis. So more than 30-40 regression method is available to according to your data. So what kind of the data you will have, and then accordingly you can apply the certain regression method. So I given you an overview of the entirely the what kind of the statistical analysis you can perform, which kind of the data is required, what kind of the objective on hypothesis, and then accordingly you can plan that you can go for regression, you can go for the p-test, ANOVA, or chi-square test, or maybe a non-parametric. Okay, so this is in my lectures. Now I think it is open for you for your question discussions, whatever you want to ask, that I can happily answer you. So now over to you all. Yeah, please tell me. Imtiaz. Yeah, please speak. I'm not able to hear you. So Siddhi Indore is asked about the one-tailed and two-tails. So let's say so far I talk about the t-test. Here in this t-test, we talk about the my null hypothesis that so my null hypothesis that all mu i's are equal and at least one is differ, means we are using the not equals to. So that means uh, we are saying that it is a two-tail test. If it is, if sometimes we know that my drug is more effective than the other drug. Okay, so we will say that mu a drug is more effective than the other. In that case, we will going to use one sample t-test. And Sanjana is asking about want to know about the dependent variable. So basically, what is the dependent variable? Dependent variable is basically nothing but what is depends means if it is some production is coming up, crop production is coming up, that's depend on the what kind of the fertilizer you are using, what kind of the uh, rain is there in that land. So that is the impacting the your dependent variables. Okay, so that's impacted by the rainfall, or maybe impacted by the fertilizer. So that's we can use. Adit, p value indicates, it's a probability value. Okay, so p value will tell you that your null hypothesis is rejected or fail to reject it. Okay, so that's we will be doing from the p value. So basically you can see this slide here, the p value is less than 0.05, that means rejecting h naught. If p value is greater than, that means fail to reject. That's you are doing in case of these two. So Lucy, can you people can speak or not? So Lucy asked about the how to check the normality of the data. I think Dharmendra, you can unmute all of them. Are you here? Coordinator, are you here? Please unmute all of them. Yeah, Lucy, let me talk you about normality. So normality can be seen with the help of the histogram. You can see the histogram, and this will give you the idea how your normality is there. But there is some test is there, Shapiro-Wills test is there. From that test, you can just see that your data is normally distributed or not. That you can do. So any other questions? Siddhi, what you want, you can compare SPSS, R and Stata as well. So you can use any software. So Aditya, how you can decide the suitable test? So as I already told you that what is your objective or hypothesis, and what is the types of the data. Let's say my data is categorical, then I can go for the chi-square test. If it is my data is continuous, then in that case I can go for the parametric method. If I want to see that the mean differences of something. Okay, so in that cases I can go for the certain test. So that's, you need to have an idea, means this is my objective or hypothesis, and then after that this kind of the data is with me, then you can decide that which test can be suitable. If both types of the data is available, then you can go for the regression analysis. You can also go for the some other analysis, but basically it's my purpose is what is my hypothesis. Okay, so my concentration is on the hypothesis first, concentration, secondly on the what kind of the data is with you. Someone is asked about the data and variables. So basically the column which is I'm saying that, so variables means it's varying for the each respondent. So let's say I'm asking from all of you, what's your query? Okay, So this is the first response. So I'm having the question that what is your query, and one participant is giving that this is my query, this is the query. So this is the variable which is varying across the students, across the participants. So in that case, in that way, you can understand the what is the difference between the data and the variable. Any more questions, please? My mail ID is Govinda. What you are asking? Can you write it again? Is, is there any other questions? So, Govinda, you are asking for the standardized movements of the data, skewness. So, skewness and kurtosis can be seen of the data, but basically, the primarily your purpose is that you want to see the normality of data. So normality of the data can be seen by the separate tests. Otherwise, you can go for the standard deviations. You can go for the quartiles, or you can also go for the histogram that will help you. Swati is asking about the can we use this test for the panel data? I will say panel data is something for you are having time series data or some organizational data where you cannot use these kind of the things, because in that case you will going to understand the what is the happening in the trains. Okay, so in that cases you can go for the time series analysis, not for these analysis. Basically all these depend on the what is your objective. If you want to see the mean value differences, then you can apply these tests. Otherwise you will refer to your time series analysis. Hello. I think now you can unmute yourself.
So thank you, sir, for your wonderful session. So I was disconnected. So I think there are no more questions. So if you have, then you can unmute yourself. So I think there are no more questions. So thank you so much, sir, for your wonderful session. And I hope participants have enjoyed. So I think we can, stop today's session.
If anyone asks any questions, you can unmute yourself. Otherwise, you can email to Dr. Dharmen.
Yes. You can write to us and we will forward your queries to Dr. Manoj. So Dr. Manoj also had shared his email, so you can directly ask. So thank you so much, sir. Thank you once again.
Thank you. Thank you,
for,
Dharmen.
Thank you, sir.
for very informative session. So thank you. See you all tomorrow.
Thank you.